Scenario: a block A of mass 3 kilograms is released from rest at the top of a 4.0 meter long plane incline at an angle of 30 degrees above the floor. After sliding down the ramp, block A has a new velocity of 6.32 meters per second, hits and sticks to block B, which was at rest and has a mass of 5.0 kilograms. Assume the friction is negligible. The speed of the block together after the collision is mostly near dot dot dot. So the question here is trying to look for the velocity of the blocks together after the collision. So the question is, do you need to use conservation of mechanical energy in this problem to solve it? No, you would not use conservation of energy. The reason why you do not need conservation of energy is because the initial velocity of both blocks are given with the mass. So you can use conservation of momentum to solve for the final velocity. We would just use the conservation of momentum equation for a inelastic collision. Next question. If you were only to use conservation of mechanical energy to solve for the final velocity in this problem, what issue would you face that makes it impossible to solve? Well, this is what the conservation of energy would look like. The mgh, which is the gravitational potential of A, it is 0 here because the block's not moving. This is equal to 1/2 the mass together times its velocity squared. That's how it would look like. The problem here is that the total mass of the system at its initial state is different from its final state. So the left hand side is the initial picture. That only has mass A in it. The right hand side, which is its final state, has two masses together there. In this problem, the mass is not conserved because you have the addition of the new mass in the final state. This breaks the conservation of mechanical energy because the underlying assumption of conservation of mechanical energy is that mass stays consistent. You do not change the mass. Okay, the only thing that is changing is the energy state of it. All right, so here that's the issue that comes across. This is the reason why you wouldn't use the conservation of mechanical energy. The first part tells you that you only need to use conservation of momentum.